Deeply passionate about Chinese culture, he shares,
我很喜欢泡茶，我很喜欢书法。
confident in China's future in mathematics, he remarks,
Your country is absolutely the future of mathematics.
urging young scholars to think independently, he emphasizes,
And use your critical thinking, but also use your creativity in thinking.
Andrei Okounkov, Fields Medal recipient and foreign member of the Chinese Academy of Sciences, sat down for an exclusive interview with Leaders Talk.
Hello and welcome to Leaders Talk, where we meet leaders, thinkers, and trailblazers. I'm Wang Guan in Beijing. Our guest today is Mr. Andrei Okounkov, a Fields Medal laureate and foreign academician of the Chinese Academy of Sciences. Now, as an admirer of the Chinese culture who is currently learning Chinese, what unique insights does he have into China and the Chinese science education? Having attended the International Congress of Basic Sciences for 3 consecutive years, how does Mr. Okounkov view China's achievements in the field of basic research and basic sciences? And why is he a firm believer in interdisciplinary integration and the transformation of scientific research? Here's our conversation.
In an era marked by transformative advances in basic science, the convergence of disciplines is reshaping the frontiers of human knowledge. Fields medalist Andrei Okounkov stands out as one of the most interdisciplinary thinkers in contemporary mathematics. His pioneering work spanning representation theory, algebraic geometry, probability theory, and beyond has left a lasting impact and forged a singular academic trajectory. In November 2023, Okounkov was elected a foreign member of the Chinese Academy of Sciences. A passionate admirer of traditional Chinese culture, he immerses himself in its practices, from copying calligraphy to studying the art of tea. Through these cultural pursuits, Okounkov seeks to explore the deep resonance between Eastern philosophy and mathematical thought.
Professor Okounkov, it's a pleasure to have you with us.
It's great to be here. 学习中文，我对中国的文化和历史感兴趣。我很高兴参加你们的演示节目。
所以您在从事数学研究和教学之外，还抽出时间来学了中文，而且中文讲得这么好。
我讲过。
您学了几年中文了？
我们学习中文在网上的1周2次，2年前。
2年前开始学中文。
开始。
Let's do the interview in Chinese.
maybe in a few years. Give me a few years to learn some more.
Yeah. This way, to manifest, to show that cross-cultural and interdisciplinary learning is so important, something that is very dear to your heart.
Right. I think what I like the best my whole life is to learn new subjects and see how they connect to something I already know. And so in terms of learning about Chinese culture and history, and 我很喜欢泡茶，我很喜欢做书法。书法，我很喜欢做书法。This sort of old things that mixes amazingly well with what China has become in terms of its role in today's mathematics, because your country is absolutely the future of mathematics. There are just so many young people, so many people focused on mastering the art and science of mathematics, mastering it really deep and really well. So on one side, it's very long history. On the other side, it's the future. Of course, what's obvious to everybody is in terms of maybe Chinese technologies and whatever, cars, batteries, cell phones, high-speed trains. But it's the same in mathematics. You have quite an amazing number of young people who study mathematics extremely, not just seriously, but passionately, and that's really impressive. Yeah.
So what did learning Chinese and studying Chinese made you discover or uncover about aspects of the Chinese culture that you thought, wow, this is something that I previously didn't think about?
Oh, many things. This has certainly made me really realize it very, very acutely, is that why Chinese people are so good at geometry. Of course, having a strong school of geometry is one thing, but also having this visual sense of things that comes with Chinese characters. That's actually been, like I said, it's not me who pointed this out first, but I can certainly relate to that. Having all this visual richness of one and the same character, many people, many epochs, many styles, and have emphasized different aspects of the same character. But also all of that is visual, is somehow relates immediately visible with the eye, and somehow that's one aspect in which I certainly makes. I mean, when we.
You're saying that learning Chinese, which is a picture-based language, dating back to ancient days, is correlated to studying geometry, which also takes spatial and abstract thinking.
Absolutely, and not just that. It's also that the characters, they have their own life, right? I mean, they're not as frozen as the letters. People approach characters in a very personalized way, and which is why, for instance, when I go to a museum, I always, if there is a calligraphy section, I always go there, because it's really interesting how their personality is reflected in the way they write. I think that is absolutely strongly correlated to why Chinese geometry school is so strong, and of course growing stronger.
Professor Okounkov, now that you mentioned tea making, let's do some of that.
Oh,
right
great,
here,
great.
right now.
Yeah.
Let's do it. This is my wonderful colleague,
Okay,
Sean.
这是什么茶？很好喝。
Can you tell what tea is it?
Wang.
Ah, very close. This is 碧螺春, right?
碧螺春哦，我的最喜欢的茶是一个中国样的姜红茶。
滇红，
姜红，
云南，
云南
非常美丽的省份。
呀，我们呢去过云南呢，去年，不，the year before that, how to say in Chinese the year before?
前年。
前年很漂亮，
四季如春。气候适中，而且是动物王国，而且那儿也产咖啡和茶，所以我很开心您体验过那儿的。我很开心您品鉴过云南的茶，因为云南的茶真的很好，就像它的咖啡豆一样，其实现在也远销全球。那 Okounkov 教授，我们一边在喝这个茶，其实我也在想 ，you have to make it 80 to 85 degree when it comes to the hot water.
Right.
In order to make the tea leaves unfold and to make the taste just right. Do you see parallels between tea making and, mathematics in terms of you have to be precise and you have to use the right parameters?
Oh yeah, that's a great point. Yeah, that's a fantastic point. Yeah, that's an excellent point. Thank you for it. It's both, right? I mean, you have to be on the one hand precise, on the other hand, people who grow tea, of course they follow the tradition, but then they add to it, right? They go. There's people who know their tea leaves well, and then what I'm trying to say. Tea culture also develops. It's not precise to the sense that you have to be the same every time. People always have this perception that mathematics is something already finished, already kind of frozen in time. People already derived all the equations, and now people just have to study it. But that's not the case. Mathematics develops. People, of course, you have to follow what people already No, you people have to learn it, have to master the techniques that are already there, but you can add to that. I mean, mathematics is a very much developed.
Andrei Okounkov was born on July 26, 1969 in Moscow, Russia. A chance encounter with a science magazine during his high school years sparked a lifelong passion for mathematics. In 2006, at age 37, Okounkov was awarded the Fields Medal, often regarded as the Nobel Prize of Mathematics, in recognition for his groundbreaking interdisciplinary research. With his distinctive perspective, he revealed how extraordinary mathematical beauty can emerge from apparent chaos.
Professor Okounkov, you won the Fields Medal. Some call it the Nobel Prize of Mathematics. And you won that, according to the committee, for one particular reason. That is, you bridged probability, representation theory, and algebraic geometry, connecting what seems to be unrelated fields, what seems to be three alien languages, but you're putting them together and making sense of it all. Help us understand how you did that.
No, that's a long question, but I'll try to answer the best I can. Every single thing is contained, everything around us is made out of these extremely tiny particles. Those behave in a random way, in really random way. And yet out of that emerges a very non-random things, like for instance, maybe molecules of water bound to each other, and then you have a river flow. And so probability concerns with things like that. But then not only the shape that emerges can be expressed by certain equations, which is what people call algebraic geometry. Algebraic geometry means shape, and algebraic means you can describe the shape by certain equations.
And I've been listening with humility, but this is not easy. Not the easiest of subject.
Easier than Chinese language.
And you also said this about the importance of interdisciplinary curiosity. Yeah. You said something like, the best ideas are often forgotten. Talk to biologists, poets, gamers. Innovation hides where fields overlap.
I think it's extremely important to have a different point of view. The same sort of, it's like, the way these cameras are positioned, they offer different point of view on you and I. And in life, it's sometimes extremely important to change a point of view. Just have a different perspective, look from another angle, and then you all of a sudden see a solution. And so it's like a big mountain, and then there's one path on top of this mountain. No, there are many, many different paths, and very often you're stuck on some path. You're much better going around and seeing from a different angle.
So mathematics in life, mathematics in action, in resolving real-world problems.
Absolutely, and so I hope I'm reaching your wide audience and telling them that the math is a beautiful subject. It's not rigid. Part of its beauty, it is based on certain logic. There's a very strong logic to it, and that helps mathematics develop because it provides a very strong structure on which you can build one conclusion upon another. But it's a subject which is very much alive. It allows for a lot of individuality. People can approach mathematics from all different angles, from all different points of view, using tools from this or using tools from that, and trying this approach, trying that approach, and that's and interdisciplinary is certainly very much part of that, because if it's like an exploration journey, you don't know ahead of time what tools you're going to need, what path you need to take. You just follow, I guess you follow your own intuition, you follow your own picture of the universe, and then you. Yeah, it's math is an exciting subject. It's really a beautiful, very modern, very exciting subject.
Something we have to show you, Professor, because it is made by Chinese filmmakers, and it is something that we're very proud of. That is the top grossing animated film of all time, Ne Zha the Second. And it's a fantastic film, by the way, if I can get it to show you. And, in this animated film, there's this episode where Naja is having his power, materializing. If you look carefully, this ribbon, silk ribbon, follows a certain pattern. Its wave, its projection, its trajectory. Some people say that it's meticulated maths in life, in action. You have to calculate where this ribbon goes and to what extent, so that it forms this integral whole. How do you appreciate that from a
that's great.
mathematician's point of view?
That is fantastic work. There's an incredible mathematics in producing even the real images. Like suppose you want to do, then when you go to images which are sort of based on the real, so you feel this whole fireball and all this kind of waves of fire that is very, very beautiful. But then maybe the next step is you can also imagine what is it like in the situation which you and I have not seen. There's this shape which it's kind of, so they imagining the shapes which are kind of really on the fringes of what the modern physics can describe. Really extreme energies, really extreme forces, and that's.
But it's really saying that mathematics can be beautiful, underlying Naja II and as well as stellar.
Yes, I agree with that. Mathematics has this potential. So this is because among other things, it's extremely rich. Mathematics describes so many different things and describes it, but it describes it in a way that you can sort of, you can imagine them and you can plot them, even though you've never seen them. And so that's the power of mathematics.
On basic science, you once said, basic science is like mapping a new continent. You don't know if you'll get gold or you'll get monsters, but without a map, you'll absolutely get nothing, that is assured.
Oh yeah, absolutely.
Elaborate on that for us.
Math is the best, maybe in some sense the only way to really precisely describe what some set of phenomena or some problem, and to give it a really precise description, you really need math, and that really empowers people to approach everyday problems with the degree of precision that is required for solution, because today's technology is really dependent on extreme precision, and if it's otherwise all these basic things that we have, miraculous devices and various whatever high-speed trains and so on and so forth, that would not be working if we didn't have that degree of precision of understanding of our world.
In July, the light of science shone brilliantly in Beijing. The Third International Congress of Basic Sciences brought together leading scientists and pioneering scholars from around the globe to explore the future of basic science. From the potential resolution of century-old mathematical conjectures to breakthroughs in quantum computing and the rapid evolution of artificial intelligence, the world is stepping confidently into the era of big science. As a driving force behind scientific and technological innovation, fundamental research is advancing human civilization with unprecedented momentum. In this dynamic exchange of ideas and intellect, a new chapter is being written in humanity's ongoing quest to explore the unknown.
And you've been coming here to attend China's International Congress of Basic Science for many years on end. Tell us about how you see the merits of this platform in terms of fostering international exchanges, deepening networks and resources, collaboration, and also expanding the scope of knowledge, perhaps.
Oh no, I think that's a great event, and it's one of many things that are going on in China in this international direction, and this serves, I think, a great. It serves many purposes, but it serves it great. And on one hand, it brings together the international, the Chinese communities in a way that really enables people to meet each other, to learn from each other, and to be inspired by each other. But it's also many people. Many of my colleagues outside of China, they have all this silly preconceptions about China. And when they first come here, or and then just see for themselves what's today's to China is like. What's how the level, the degree to which the culture, the technology, the people that they advance, they certainly feel like they're becoming more and more and more.
So China over the years has been making some notable progress and breakthroughs in a number of scientific and technological applications and also basic research. What do you think China did right? What factors contributed to what looks to be a collective rise in China's science and tech?
I don't think I can name every single reason, but certainly the basic thing that Chinese people appreciate learning, they learn, and they use their heads to process what they have learned. And this is not something new. This has existed in Chinese culture for thousands of years. Maybe now it was more of a pivot towards STEM subjects, but the idea that you should learn and you should use your head to process what you have learned, that is unfortunately something which in some other countries, teachers have real difficult time convincing students to do, because it's somehow...
It's hard.
It's hard, yeah. Once it's hard to make people do what they don't want to do.
Yeah.
But Chinese people want to learn. They want to use what they have learned to make better things, to create new theories, to create new practical things. Just great. What can I say? It's great. And I think I'm not... I hope other countries do something similar, just because the leadership is where the people are, and the people here are really serious about STEM.
Chinese President Xi Jinping has been emphasizing that innovation is key in driving development, and he really encouraged young people, young men and women, to go out there and explore uncharted waters and unknown territories. And there have been a number of initiatives and strategies in place to really, foster this environment of innovation. How important do you think these guiding initiatives and projects and strategies are in terms of having this enabling environment for China to have more innovation, have more young scientists and science lovers?
I'm a foreign member of Chinese Academy of Sciences. So last year I was in Renmin Dahui, and then listening to Secretary General, and he kept on going for a long time, emphasizing what you said. And it's great. I mean, what can I say? It's just the fact that the Chinese government supports people in learning and in making innovation in science, technology, mathematics, other basic sciences. That's just, what can I say? That's great. I think that's great for the government. And I certainly think that the basis for all of that lies, the basics for the prosperity in the modern society certainly lies within the successes in technology and science. And if the government places an emphasis on that, I can only salute that effort. I think it's just great. What can I say?
And that's partly why you've been in China quite frequently over the years, and assuming the teaching job, interacting with the students here, doing part of your research here.
Like I said at the beginning, I appreciate both sides of China. I appreciate its long history and its cultural tradition, but certainly it's obvious that this is also the land of the future as far as mathematics is concerned. And so I certainly like to use every opportunity, this meeting with you. So I like to use every opportunity to encourage people to study mathematics, to either go into mathematics or at least apply mathematics in their everyday life, and so many people do it. I think I'm quite certain that mathematics will have a really bright future in China, and by every indication, China will be the global leader in mathematics.
Let me pour you some tea. I think it's getting dry, huh? This season in Beijing is pretty dry season.
Yeah, it's pretty dry, yeah.
I know. But Professor, do you worry that in a time of algorithm, big data, and artificial intelligence, people are not, become
using
better
their
critical thinkers, but less able to think critically and objectively about things because they rely on so much of the feed that they get, the news, the music, the content that they have a preference over previously, reinforcing their stereotypes instead of stimulating them to, step into and venture into new territories of knowledge.
I mean, I would be lying if I say I don't worry. I do worry, and it's very clear, and it's, again, in biology, it's extremely clear. Once you don't need something, then the evolution doesn't support that. Like, for instance, our predecessors, they had the ability to produce, for instance, vitamin C. But eventually the diet has changed, and now we depend on outside things. Because it used to be that people were, for instance, you can very easily test the ability of yourself or other people to navigate some terrain without using cell phone maps. And you will discover that people have no idea where is north, where is south, kind of the obvious things. So what our predecessors were extremely acute, which what is the time of the day based on what the sun is, and what are the signs that the rain is coming, and where is north, where is south.
The GPS to go to the supermarket.
Exactly.
To their gym.
Exactly. But the serious thing about it is that in biology, it's always like this. Once there is no need for a certain function, that function is not supported evolutionary. So that means this function will just lose the ability to do that. This can really happen to critical thinking, which does worry
I think
me.
that's called atrophy.
Exactly, that's the word.
As one of the most decorated mathematicians and the top mind in science of our era, Professor, finally I would like to ask you to give some tips and advice to aspiring youths who are watching this program, who aspire to make a difference in this world, in this life, in becoming a scientist and mathematician.
Oh, thanks for this opportunity. Maybe can I go back to what we just discussed? Because I think this is what you said about critical thinking. I think that may be the most important thing. So because you will, it's easy to be mesmerized by the modern science of technology, and it's an extremely beautiful thing. But as you learn it, try to use your head. Try to absorb the information, making sure what you learn is true, and use your critical thinking, but also use your creativity in thinking.
Professor Okounkov, I think it's fair to say that you led by example in venturing into even learning Chinese, what's said to be one of the most difficult languages in the world, in fostering this interdisciplinary discipline. Let's put it that way. And thank you for the example that you have been.
Thank you for this opportunity. It was great. Thank you.
Mr. Okounkov really had a thing for traditional Chinese culture, learning Mandarin, calligraphy, tea making, you name it. That passion comes through so vividly in the entire interview. He mentions how China's rich historical and cultural heritage pairs fascinatingly with its remarkable achievements in mathematics today, creating this interesting synergy. Thank you for tuning in to this episode of Leaders Talk. I'm Guan in Beijing. I'll see you again next time.